Good morning, good afternoon, good evening, wherever you are in the world. Thank you for joining us and spending the next 10 or 15 minutes with us. My name is Steve Robinson. I am one of the business development guys at Galarath. I am based in the UK, as is my colleague Keith Garland. Our details are on the screen in front of you. The purpose of today is to introduce one of the new capabilities that we've got within the SEER suite of estimation tools, specifically designed for design to cost activities. We have developed the SEER 3D capability to read step files, feed those that information and associated manufacturing rules into SEER for manufacturing to produce very quick, very effective estimates of component manufacture. SEER 3D is capable of operating and working with machined components, sheet metal components, composite components, and in the case of the next 10 to 15 minutes, additive components that are created using an additive manufacturing process. This is the newest addition to SEER for manufacturing and is, as I say, the latest addition to the SEER 3D capability as well. Keith is going to go through the demonstration. We're going to talk about the capabilities in a general high level sort of framework. There will be more detailed sessions later on that go into some of the specific areas of the tool and its broader capability. If you have any questions, please feel free to drop Keith and I a line. If we can help, we will. If we can't, we will find somebody in the organization that can and get back to you as quickly as we can. But without further ado, I will hand you over to Keith to go through the presentation. Keith, it's over to you.
Thank you, Steve. Hello, everybody. So today we're going to be looking at SEER 3D, and in this case we're going to be looking at additive manufacture. So on my screen now you can see the GUI, the interface for SEER 3D. It's the same interface for machining, for sheet metal, for composites and additive manufacture. The only thing that changes are the input questions, the selections, etc. So the process is, the first stage is import. I have done that. I've just brought in a simple component. And then from there, we select what process we wish to choose. So each version of the tool, whether it be machining, additive, composite, or sheet metal, are licensed independently. You can have 1, 2, 3, 4 options and any more as they come along, depending upon what your need is. So today it's additive manufacturing. And then it's a case of choosing the process through the manufacturing environments that best suits the additive process that you wish to utilize to create the part that you're going to estimate. So as you can see, we have direct energy deposition, fuse deposition modeling. This is just a sample for one of the customers. We have liquid phase laser sintering, selective laser sintering, and stereolithography SLA finally. So we'll just select direct energy. The process is direct energy, and then we'll enter a production quantity. And what are we going to make it from? So you can have a single material, you can add other materials, you can take them from the drop-down list, and because it's SEER for manufacturing, you can add your own materials to the material ini files and build in your own blends of materials maybe, or you can utilize this, add additional materials to say it's 50% aluminium, 50% nickel, whatever you want to do to create your part. So within this process, it's what is the material form, so we can choose between powder or wire. The bounding box, not that important in this case, but you can change its orientation. You can use defined the orientation as well. And the sizes are generated from the rules file, which is adding on an addition, and the part shape geometry. So we can just turn that off if it's no interest to us. So as you can see, you can easily manipulate the part, have a look. You can quickly zoom into features, highlight. We can then do some measuring. So we can have a look at the length of an edge maybe. Select length of edge, missed it. And there we go. This is 18.67 millimeters. You may wish to know for various reasons. You can do distances between faces, lengths of curves, and so on and so forth. So that is just one of the features of the model. Go back, turn it around, inspect it, see what we've got to do. And it's a nice perfect example for additive manufacture. So we've done what we can do here, and we come down further. So how many parts are we going to build? Parts per build, and we can just simply increase, decrease this based upon the size of the machine that we're utilizing, the size of the bed, its capability. So the print resolution, obviously, this is ranked in the help based upon the scaling factor, so that the higher you make this resolution, the greater accuracy you're going to have, the finer shape definition will be, etc. So as we change that, you'll see the layer height alters. If you didn't see it, I'll change it again. So go from nominal, and then it gets much bigger, and so on. So we'll just come somewhere in the middle. We'll say it's going to be high, which gives us an infill percent of 75%. We can change the trace width if we want to, the support content percentage, and that's calculated as a support infill. These are the geometries extracted from the step file, and then there's other processes here we can turn on and off as part of the options. So we can do isostatic pressing, we can tool fabrication and design, and again, the rules and environment files controls the defaults for these processes. It controls whether you want these turned on and off. And another session will be on how to build and create environments within SEER 3D. They all work in a very similar way. They each have a folder. The folder consists of an Excel workbook containing rules, some of the features that you may wish to capture, some of the defaults you may wish to set for the part family, the process families which you wish to employ within that environment. It also has a SEER for manufacturing folder which contains work elements which are saved in turn as knowledge bases for use with that specific environment family. These will contain things like the tooling list. So what tools are required to produce this? What are the finish and heat treatment operations you may wish to have as default for a part of this type? It may be a sanding operation, it may be a blasting operation, it may be a painting operation, treatments, whatever it may be, you can do that also. So these are contained and controlled in the environments, in the knowledge bases, and I'll leave them on so that when we run the model, we can see the resultant estimate and what is brought in automatically on our behalf. So we're complete. We've done all we had to do. Just a single tab to go through, and then we will click on the estimate button, and now SEER is going to start up SEER for manufacturing in the background. It's extracting all the information, the geometry, the information from the rules file, the information from the knowledge bases, and it's going to create an estimate which should pop back up. There we go, onto the screen. And as you can see, we have a roll-up, which is the level 1.1. Below that, we have a direct energy deposition work element, which is an additive manufacturing work element, a pressing operation, and a finishing operation, which is all created based upon the knowledge bases. I think at this point we'll have a quick introduction to SEER for manufacturing. So this is the costing engine that sits behind all of our 3D solutions, SEER 3D for machining, composite, sheet metal, and additive, and also the costing engine behind our CATIA solutions for sheet metal machining and composites. So we have this 4-pane configuration. These are the building blocks, the processes here. Each one of these work elements represents a process. This is finish and heat treat. This is additive manufacture, and this is mold cast forge. These all add up together, and the costs are rolled up into this work element here. when we work in the work elements, we have tabulations here. The general tab is common. Tooling, inspection, part mark and package are common across all the processes. The only thing that really varies is the process specific, and they will obviously alter dependent upon the process that we're estimating. So the general tab is where we've brought in our 100 and our batch sizes of 10. Is brought in the labor rates, production experience and optimization. At this point, I can tell you that we have our 3-point inputs. We have a least, a likely, and a most. This will allow us to quite quickly capture uncertainty. So very early on in the life cycle, maybe we don't have all the information. We might not have a finished design. We may not know where it's going to be produced, and so on. We might not know exactly what the material is. So we can make assumptions. So it uses a PERT mean average, where it's going to take 4 of the likely, 1 of the least, 1 of the most, divide that by 6, and that's the resultant value that will go through into the algorithm. Production experience is a good example, because in the average machine shop, we don't know where it's going to go, but what we do know, some people are very good, some people are average, some people aren't so good. So you could have a range of capabilities if that was how you wanted it to be. So I tend to basically use something like this, where we have some very good people, some superstars, and some not so good people. These may be apprentices, they may be semi-skilled workers, all adding their value to the company, but they're not have that time experience to become at the top. So this is the sort of way you would use the 3-point inputs. And anytime you have uncertainty such as that, the model also has Monte Carlo risk analysis, which will allow you to do risk analysis, look at your least likely, from your 10 through to your 90 confidence levels for your 3-point estimation, should you wish to use that capability. Labor calibration is just a linear multiplier. We can add steps, we can add learning curves, we can add financial factors. The model also works in multiple currencies, so we could make this part in the USA, this part in Germany, and get it finished in China. So you can work with 3 different currencies, and all of their costs would be wrapped up at the top level into the default currency that the project was started in. The bottom half is model outputs, reports and charts and so on. So this gives us the ability to look at the outputs, the numbers, the values that we've estimated for our given operations, for our presses, for our finishing, and the total costs at the top here. We have detailed analysis reports where we can look at more detail, material costs, direct cost, setup cost, inspection, rework, and so on, the cost for 1 unit, the cost for 100 units across the piece. So the work elements themselves, process specific in this case, we come down. What we can see is we've selected that from the environment, brought in the geometric sizing of our component, and then these are the process parameters that were either set by the interface that we change, layer height, thicknesses, infill percents, trace width, were all factors that we could affect. The others were brought in by either the knowledge bases or the rules files, dependent upon the processes that we were going to estimate. And then from that, we have our resultant estimate straight away out of the box for this given component. So as you can see, a wide range of processes. This is the press operation here coming in. What's the press? Hot press, isostatic pressing. And again, if I select this one, you'll see some of the capabilities within SEER of all the other processes available within Moldcast for work elements. I'll just cancel out of that one. Back to 3D SEER MFG, if I insert the work elements, you'll also see now I could do, I don't know, let's say I could add a machining operation. So I'm going to say drill holes. I'm going to copy the common parameters, put it in at the same level, click on OK, come to the General tab. Everything's been brought in, process specific. Again, I can take the information from here. I'm just going to put, for speed, it's 1 kilogram. I don't know what it is, but then I'm going to say it's aluminium alloys operation here. And you'll quite quickly see that I can add some drilling ops. I just pressed a D there, but I could have used the drop-down menu. As you can see, a wide range of machining ops. So I'm going to drill it. I'm going to put tooling hole. I got one of them. Its depth is going to be 6 millimeters. Its diameter is going to be 8. No packing, no reaming, load and unload, click on OK. And I've added that to the whole, to the operation. So it's very straightforward. So you have the full capability of MFG as well as the benefit of 2D when you're doing your estimating process, such as this. Reporting, so we come back up, reports and charts and cost analysis. Let me come to the top one. So we can see where the cost contribution is taking place. And I've come down lower. Operational analysis, we can see in more detail. If I double click, we can have the ability to take this out. So if we have the luxury of 2 screens, we can drag this over onto a screen. So our cumulative costs coming up. And then this is how the part costs breaks down for this one given process, which is very useful. And at the roll-up level, I'll just show you it again. The work element contribution shows us of these operations, where is the time going to be consumed, and so on through that process there. So that's reports and charts. They do cost sensitivities, cost risk. I'm on the wrong place. So this is the S-curve. So this is showing us the confidence level in our estimate. So we have a 10% cost that we could do it for 55.82. We have a 90% confidence we could build it for 75.99, and that's based upon the uncertainty that I mentioned earlier, embedded into the knowledge bases and our inputs that we could manually override. Operation details report, nothing there. Detailed analysis, double click this one, and again, all of the reports can be taken out. We can export the reports here. We can look at the volumes, the sizes, the times, build speeds, etc. At this level, a little bit more detail where the cost is being consumed within the overall project, and again, our setup, direct inspection, rework, etc. If I come back to this one, I just want to show you now, we'll basically break this estimate, but what I wanted to show you is the other processes. So do jetting, click on OK. Again, the inputs will now have altered here. Sweep layers, delay time, print resolution, layer heights, and again, change that to powder bed fusion. Click on OK, and how the inputs will vary. And don't forget, you can do this in SEER 3D, you can do this in SEER MFG as a native estimate. So this is just another work element in MFG where you can build this up manually. And again, you can save knowledge bases to create other knowledge bases to speed up the processes. Stereolithography, click on OK. And again, select your materials and all of the inputs that become available. So it's a very comprehensive process. Done that one there finally. And again, how the inputs change based upon the process change. So that's SEER for manufacturing. This is the resultant estimate. Just to recap, back here, we import the file. We go to the general tab, we select the process we wanted to use. We wanted additive. I'll just select something randomly. We'll say selective laser sintering. Powder bed selected, ignore that one. Have that one, make 100. Click on OK, and then verify the rest are OK. Click on estimate, and the model will create a fresh estimate. And that's as easy as it is. So that is SEER 3D for, here we go. I didn't select the binder. There it is. Let's done the estimate. So thank you very much for your time. Pass this one back to Steve, and he will close. Thank you.
Thank you, Keith. So yes, that's SEER 3D for additive manufacturing, as well as a bit of detail about what SEER4 manufacturing is itself. If that has generated any thoughts and questions, our details are on the screen. Please feel free to reach out. As we said at the beginning, and it's been mentioned throughout, there will be additions to these series of recordings that will go into detail in some of those specific areas, such as the generation of those manufacturing environments that Keith talked about. So it just leaves me to say thank you for your time. I hope you found it informative. If you have any questions, please reach out to us. We will be more than happy to help. Thanks very much.
Thank you, Steve. Goodbye, everybody.